All right, we're going to get started with Chapter 4, which is a unit on collecting data, design of studies, that type of thing. Very important unit, but we're going to do it. Section 4.1 is about sampling, 4.2 is about experiments, and 4.3 is kind of putting it all together. All right, so to start off, we did a classroom exercise, or perhaps we did a classroom exercise in your class. The Federalist Papers. So it's a series of essays in order to encourage people to ratify the U.S. Constitution. Basically, there was 85 essays. Some of them were, the authorship of 73 was known, however 12 were kind of unknown. So one thing that some people do to try to figure out who writes a text is to look at the average word length. Now it may seem a little bit crazy to think that certain people have an average word length whenever they write, but there's been some success in statistics predicting authorship by looking at the average word length. Kind of a simple idea, but so the bottom line is we want to get the average word length for every word in a passage. So we want to find the true mean word length. Okay, so what we should do is we should just record every single word, start adding them up. There's a 2-letter word, there's a 4-letter word, so on and so forth. Create a list of all the word lengths and then average them up, right? But that's a lot of work. We don't want to do every single word, so we're going to simplify it by taking a sample. Okay, so in the class activity, I'd have everybody take a sample. I would say randomly pick 5 words. So maybe you would pick words like inadequate, hazard, supplied, government, and principles. Okay, and you can pause the video and do this if you would like. And then I'm going to average those. So I'm going to find the sample average, right? So I took a sample of size 5, and I'm going to take the sample average. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. I'd add up all the word lengths that I got, divide by 5, and get my sample average. Let's just say it was like 7.8. Okay? Then I put a little dot here at 7.8. Okay? So I'd have everyone in the class repeat that, do that, and then I would record a dot plot. So I did this in 2 of the classes before I made this video, and we got something that kind of looks something kind of like this, right? So each point on this graph represents a sample of size 5 where we calculated the sample mean. Sample mean was maybe 8.7. So this isn't a dot plot of data, okay? This isn't like one word was 2 letters long and one word was 4.3 words long, right? Letters long. This is a plot of sample statistics, okay? This is going to have a special name called a sampling distribution down the road. It's a sampling distribution of sample means, okay? So it's going to be a little bit different, and it's going to be something it's going to be an important thing to talk about down the road. But for right now, let's just look at it as a regular data plot. So each person, like I would, my best guess for the average number of letters per word would be 7.8, because that's all I got. I didn't have these other data points. If we compile them all together, though, we could come up with an overall best average. And so I'd ask the class, what's the overall average you would think? And most people say we'd want the middle of this distribution, maybe the mean of our means. And maybe we would guess right around 6.8 or 6.9. Maybe our estimate would be 6.9. Okay? That would be our best guess. So then the question is that a good guess? Do you think the average word length in this passage is pretty close to 6.9? So maybe you can pause the video and think about that. So, now I said randomly pick words, but we didn't really use randomization at all. When we say randomization in statistics, we're talking about a probabilistic type of process, like a chance process. So instead of us just picking words, the human mind cannot randomly do anything. We just can't. If you say pick 5 random numbers between 1 and 10, if you say 6 on the first one, your mind just knows that you said 6, and you'll be less likely to pick 6 on the next one. It's been tested over and over again that the human body isn't very good at doing random words. So this time what we said, well, let's actually use a random process. So here is a list of all 130 words in the passage. There's 130 of them. Now we want to use an actual chance process to do this. So we're going to use a function in our calculator called the random integer function, where we put the lower bound, the upper bound, and then the number of values you want to generate. Okay, so I want to do random integer from 1 to 130. So if I just hit enter on this, it'll generate 1. If I put a comma 5, it'll generate 5. I'm actually going to generate about 8. Because if I end up getting a repeat, and I know that's probably a pretty small chance, if I end up getting a repeat, I want to kind of throw out that repeat and pick the next one. So I'm going to generate a couple extra in case I get repeats. So I'm just going to take the first 5 unique values. Okay, so on my calculator, by the way, to show you where that random function is, menu, probability, random integer. So if I just do 1 to 130, it'll generate 1. But if I do 1 to 130 and I put a comma 8, it'll generate 8 of them. So my first one is 119, so I'm going to circle 119. My second one is 20 and then 67, 20, 67, and then 53 and 96. 53 and 96. So now I have a sample of words that was truly randomly generated. So now I'm going to add up those. X bar equals, we got 1, 2, 3, 4, 5, 6, 7, plus 2, plus 3, plus 2, plus 1, 2, 3, 4, 5, 6, divide by 5. Go ahead and type that in your calculator if you care, or maybe you do your own. And then I plot that value. I think that value would probably be right around, I don't know, maybe 4.2 or something, right? So then we came up with a class generation of about 20 or so average word lengths. Again, every point on this graph is a little sample of size 5 where we calculated the sample mean. So it's a collection of sample means. But notice these distributions look very different, or they look like they're centered at a different value. On this one, and in each class, I kind of said, what's your best guess? And I'm not lying to you. One of the classes, most of the classes were right around 5 or 4.8. I think one class actually said the average was 4.9. Just saying. Sorry, best guess. No, that's not the actual. Our best estimate is 4.9. Okay, so then the question becomes, which one of these is a better guess? I mean, we had this ones from human generated that we guessed in like 6.9, and we got these ones that were actually truly randomly generated. We got about a 4.9. And if you look down here at this section here, the actual average was actually 4.9. So I know it sounds a little bit ridiculous, but you'd be surprised. In one of the classes we got exactly a 4.9, and the other class I think it was really close, if not the exact same as well. Okay. So the idea is that a good sampling technique is going to give you estimates that are kind of centered around the true value. A bad sampling technique is going to give you estimates that are centered around a value that is not the true mean of the distribution. Okay, and we're going to learn that the word for this is going to be bias. Biased. Okay. This sampling technique has bias, and I know you know what the word bias means. We're going to define it more clearly. You know, we're going to come up with a statistical definition that I want you to really to adhere to this year. But that's the idea. And the reason why, and you guys could probably surmise it, is that when people are looking at it, you know, my words down here, I got so, may, and of. People are not really drawn to words like of, so, and may. They're drawn to more interesting words and usually bigger words. In fact, some people might actually pick the biggest words in the document. Sometimes people say, well, I'm going to actually do a random process. I'm going to close my eyes and I'm going to slap my pencil down, and whatever word I get, I get. But the idea is if you just slap your pencil down, you're more likely to land on you're 5 times more likely or 6 times more likely to land on the word government than to land on the word of. So that would be a bias technique as well. It's biased towards larger words. Okay? So the bottom line, the takeaway is humans cannot generate, suck at generating random numbers and random samples. Okay, we cannot rely on humans to just pick what they think are random. Okay, so whenever we pick these words, we're not going to say that was random. We're going to say that was like just recklessly picking words. That's not randomly. Down here, we actually used a random process. We used a chance process that had probability associated with it. Okay? All right, I'm going to stop this video here and get on to the section 4.1.